Hello, I am Mr. Buckley, and if you are looking for help on your Unit 0 Quest review, then you've come to the right place. We're going to start out with these order of operations problems. Now we know that the order of operations has a helpful acronym. Oopsies. It's called PEMDAS. It stands for parentheses, exponents, multiplication, division, addition, and subtraction. Now, I like to keep multiplication and division and addition and subtraction together because those happen at the same time. Even within parentheses, the order of operations still applies. So if I see my parentheses here, despite the fact that the subtraction sign's on the left, I'm still going to divide first. Now, whenever you're doing these problems, you want to leave every number and operation the same way you found it until you solve the problem. So we're going to go to the next step, 8 minus 3, that's in the parentheses, so that comes next. And we're still going to keep our 5 in parentheses because there's a 4 on the outside. Now, whenever a number is next to the parentheses like this 4, that means multiplication. And so despite any temptation to add the 8 and the 4 first or do the 19 minus 8 first, it's actually the 4 times 5 that comes next. From there, we're just going to work left to right because addition and subtraction happen at the same speed. So 19 minus 8 is 11, and 11 plus 20 is 31. We have a similar problem with number 2. Number 2, we have 2 sets of parentheses, so we're going to work left to right within those parentheses, following the order of operations. The first thing we're supposed to do within this parentheses is the exponent. Then after that, we have the 144 minus 3. I don't need the parentheses anymore because there's nothing being multiplied. And finally, we're going to take care of the parentheses on the far right, which becomes 12. And again, there's nothing being multiplied by it, so I don't need to keep the parentheses. From here, we're going to follow the order of operations. And that calls us to do the 5 squared next, as it's an exponent. And from here, it's just combining like terms with addition and subtraction. So I'm going to do 141 plus the 25. It's 166 minus 12. And 166 minus 12 is 154. So that is our answer. Our next type of problem is a combining like terms problem. In these types of problems, what you want to do is you want to keep track of all of the terms that have the same variable with the same exponent. Notice how both of these pink shaded ones have a squareds and the yellow shaded ones have a's next to them. And then here's the 24 all by itself. Anything that is shaded the same color is going to be something I combine, which is why I use my color codes to help me. So here we have a squared minus 3a squared. So pretend there's a 1 here. If there's no variable, there's always a 1 out front. And so 1 minus 3 is negative 2. Now notice that the exponent next to the a does not change. We're still squaring that a. Same thing with the 7 and the 9 a's. We add 7 plus 9, and we get 16 a's. Now the 24 has nothing to combine with, and so that stays the way it is. Notice once again that we have all of our terms combined, and the only things left have different variables with different exponents out front. That's how you know you're finished. You cannot combine anything left because they do not have the same variable with the same exponent. Another classic example of this is the problem below. We have 3x plus x, and we have 7y minus 21y. So we're going to combine them appropriately. Again, there's a 1 here. 3 plus 1 is 4 x's. 7 minus 21 is negative 14 y's. Notice that subtracting is the same thing as having a negative being added. When it's calling to write an equivalent expression, I've seen a lot of students write expressions similar to this. And that's a possible answer, right? Notice that the 2x plus the x will eventually become the 3x. However, the real thing that we're trying to get at is the distributive property. And so if I have a 5 out front, that's telling me to multiply that 5 by everything on the inside. So I'm going to do 5 times the 3x, which gives me 15x, and 5 times the 7, which gives me 35. Now the same thing applies if there's a negative here. Again, there's no number next to the negative, so we'll treat it like it's a negative 1. And we'll just distribute that negative or distribute that negative 1 to both terms. Negative 1 times 4 is positive 4x. And negative 1 times 5 is a negative 5, so we'll get minus 5 there. We're going to use this distributive property when simplifying the next problem. Now, according to the order of operations, it might be tempting to think that you would, do this 13 minus 5 first. But remember, this minus 5 is multiplying by the parentheses, and so we need to distribute that negative 5. So we end up with 7x plus 13 plus, because negative 5 times negative 3 is a positive 15x, and negative 5 times the negative 8 is a positive 40. Now notice we have a bunch of different types of terms. So I'm going to get my highlighter out. I'm going to highlight the like terms the same color so that I know what I'm combining, which makes it easy for me. 7x plus 15x is 22x. 13 plus 40 is 53. And hey, maybe it looks like I've made a math mistake. Oh, can you find where my mistake was? I forgot this 2x here. Let this be a reminder that even the most seasoned of mathematicians make mistakes. So this is not 22x, but this is 24x plus 53. I noticed that my answer was not an option, so I knew I would have had to make a mistake along the way. And it turns out my mistake was forgetting this 2x. Now this last problem, we have to pay attention to the equal sign. And so when there's an equal sign, we need to make sure that the equal sign is telling the truth. So for example, if I'm looking at the left side, I see 5x plus 7x. And so in order for this equal sign to be telling the truth, I need to be watching out for how many x's should be on the right side. Now if I see 5x and I add 7x, that gives me 12x's. And so now I know with 12x on the right side, that that's the same number of x's that's on the left side. Similarly, I see that the right side has a positive 2, but the left side starts out with negative 4. In order to compensate, I need to add something to negative 4 to make it positive 2. And that number happens to be 6. Now that I have negative 4 plus 6, I will get the positive 2 that is on the right side. And these two expressions are now equal. Similarly, in this problem, if I'm paying attention to the equal sign, I notice I have a minus 12 on the end here. I start off with minus 2, and there's supposed to be some number out front. Now, if you remember, there's no operation, and so if there's just a number sitting out front, that means multiply. So I need to think, what am I going to multiply negative 2 by to get negative 12? And the answer is 6. Well, now that I know that this answer is 6, I see that I have 3z on the inside, but I'm multiplying that by the 6 here. What's 3z times 6? Well, it's 18z. And now I've guaranteed, once again, that both sides are equal. As always, please don't hesitate to reach out to your math teachers with questions, and I hope you all have a wonderful day.